This is Unit 0, Lesson 3. This is going to be a pretty quick one today, which is nice. Just a couple of things you should be aware of in terms of the history of chemistry. Again, the AP Chem test is not a history test. These are some basic things that you should know, just kind of in general ideas about chemistry, about life. And we've talked about some of these things already. One of the first people that really talked about chemistry was an individual by the name of John Dalton, and he kind of came up with these 5 different ideas. And he said, number 1, that elements are made from tiny particles called atoms. Again, nothing specific here that you need to memorize or know. And then he said all atoms of a given element are identical, and we know that now, today, remember this is back in the 1800s, that this is not exactly true. We're going to learn about isotopes in Unit 1. The atoms of a given element are different to those of any other element. The atoms of different elements combine to form compounds, and atoms cannot be created or destroyed in a chemical reaction. They're simply rearranged to form new compounds, and that is called the law of conservation of mass. And we're going to learn all about this stuff later on. This stuff right here, I'm not worried about this really at all. It's just, it used to be part of the AP stuff. It's not really part of it anymore. Don't worry about that necessarily at all. Okay, here's the part that we do want to focus on here. It's about the parts of the atom. So a lot of times when you draw an atom, there's 3 parts to the atom: the proton, the neutron, and the electron. The protons, for example, have as you can see here, a positive charge. So a lot of times when we draw a proton, we put a circle with a plus in it. When we draw a neutron, we put just a circle, sometimes with nothing in it. Sometimes you'll see it with actually like a 0 inside of it. And then the electron is found as a circle with a negative charge, many times written that way. One of the main things that you need to recognize here is that the mass of the electron is almost 2,000 times less than the mass of the proton and the neutron. So when the number of electrons change, it does not affect the mass of an atom. If the protons or the neutrons change, absolutely, that does affect all of the mass virtually of the atom is found in the nucleus where the protons and the neutrons are. That because the electrons have such a small mass that when you change those electrons around, if you add electrons or take electrons away from an atom, it does not affect the mass of the overall atom. Okay, 2 of the things that you should be familiar with as you think about the element carbon on the periodic table. See, carbon, there's a number on the top and there's a number on the bottom. The number on the top is this number right here. It is what's called the atomic number, and at 100% of the time, without fail, that is the number of protons in the nucleus of the atom of that element. Every single carbon atom that exists contains 6 protons in that nucleus. Okay? And because in an atom, atoms are neutral, which means that the positive charges are equal to the negative charges, that it also tells us the number of electrons. So it's the number of protons here in the nucleus. It's also the number of electrons. So a carbon atom has 6 protons and 6 electrons. Okay, but do note that when atoms lose or gain electrons, the protons and the electron numbers become unbound, so they're not the same anymore, and we don't call them atoms anymore because they are no longer neutral. Okay, these are called ions, and an ion is just a particle that has a charge. Okay, you can have negative ions. A negative ion is formed when an atom gains electrons. Well, why is it, when it's negative, why is it gaining? Because remember, electrons have a negative charge. Remember that up here, that electrons have that -1 charge. So if you add electrons to an atom, it's a negatively charged ion, which means it now has more electrons than it does protons. Okay, and when that happens, that's called an anion. Okay, if an atom loses electrons, then you form a positive ion, because now you have more positive charges, you have more protons than you do electrons. So in this case, it loses electrons, it has a positive charge, and that is called a cation. So you've got anions and cations. Okay? And now this number here on the bottom has lots of different names associated with it. As you can see right here, sometimes we do call it the mass number. Sometimes we're going to call it the molar mass. Sometimes you'll even hear it just called the atomic mass, which means the mass of the atom. The molar mass is the mass of a mole, if you remember moles from general chemistry. Okay, but there's, again, lots of different ways to describe it. Not a big deal. Any of those work just fine. Okay, and that mass, remember what we talked about earlier, is that the electrons weigh about 2,000 times less than the protons and the neutrons. So this mass number right here only is affected by the protons and the neutrons. So that number here on the bottom, we just round that number to the nearest whole number, and that is the number of protons plus the number of neutrons in that atom. Okay, so in this case, carbon would have 6 protons, 6 electrons, and 6 neutrons. Okay, something like, let's think of the element bromine. Okay, bromine has an atomic number of 35, and it has an atomic mass of 79.904. So that means that a bromine atom has 35 protons, 35 electrons, and 79.9, we'll round that to 80, and then 80 minus 35, I believe, is 45 neutrons. Okay? And in order to represent the atomic number and mass number, so a lot of times you'll see it like this on the periodic table, but many times in chemistry you'll see it written like this, where the atomic mass is actually the number on the top this time, and the atomic number is the number on the bottom. Okay, so if we look at, for example, Cl minus, if you're just told how many protons, neutrons, and electrons are in a chloride ion, you find chlorine on the periodic table and go, oh, it has 17. It's number 17, so it has 17 protons. That negative charge means you've gained 1 electron. So instead of 17 electrons, it means you have 18 electrons. So again, a minus charge means you've added that many electrons to the protons. And then, because it's 35.45 is the molar mass, we're going to round that down to 35, and 35 minus the protons is 18 neutrons. Okay, we've got one lesson left after this that's about naming. That, again, remember guys, this is just the introductory stuff. They're not going to have specific questions about any of this stuff on the test, but are they going to use the terms cations and anions? Of course they are. Are they going to use terms like atomic mass or mass number or atomic number? Of course they are. So yes, you need to know. It's almost like you need to know this stuff to answer the real question. These aren't the real questions. These are you need to know the stuff to understand the question, so then you can answer the question. Okay, and that is it for that lesson.